Okay, hi everybody. My name is Alex Danilo. I'm in Developer Relations and on Chrome, and I have today with me Alexis Deveria from Adobe. Alexis, of course, is the man who built the site caniuse.com, which is a fantastic resource for anybody doing HTML5 development. We're going to show you a whole lot of stuff today. We're talking about CSS filters, but most of all, we're talking about a new next-generation reading experience. So this is built with not just CSS filters, but a whole lot of web technologies. So we're going to cover stuff that uses WebGL, uses SVG, uses Canvas, uses a whole lot of stuff, all working together to bring you a seamless experience. And of course, this is all about trees, okay? So when we talk about DOM trees in the browser, we get excited, or at least I do. I don't know about you guys. But of course, today we're talking about the world's biggest tree in mass, and it's called the President, and National Geographic have this beautiful, beautiful site that they've built with Adobe's help. And we're going to talk all about that today. So, what are CSS filters? I'm sure you're asking. Well, you build these beautiful DOM tree things inside your browser, and then the browser comes along and it goes, well, we need to see that thing. So the browser lays it out, places all the elements on the page, and then it gets styled, and CSS comes along and styles it. And then we have this post-processing step, which is a CSS filter. So if you can imagine baking a cake, you get all your ingredients, you put them together, you bake it, that's your web page. You want to make it look good, so you put a bit of icing on the top, and then you sprinkle sugar, and CSS filters are the sugar, which makes it look even better. And so once you've done the filter, you then push it to the screen. So once you've generated a bitmap, the bitmap can be filtered inside the browser, and then that eventually ends up on the page, and that's what you look at. So where did this all begin? This all began with SVG, of course, you know. Now, that SVG is a graphics language, which you all know from HTML5, and within SVG there are basic filter primitives. But these filter primitives are like building blocks, so you kind of combine them all together to end up with the effect that you want. So if you have a look at this graphic at the top, we have like a standard graphic on the left, and then we generate a blur from that. So you take the blur, and then the second filter offsets that blur a little bit. The third filter puts lighting on the blur, which then gives you this kind of 3D effect. The next filter along the chain clips the blurred lit piece to the original graphic so that it only hits the original graphic. The next stage of that pipeline combines the original graphic with the filtered piece we just created, which gives you this nice little 3D with the second last image. And then following that, we add the drop shadow from the second stage again, and we get this nice drop shadow 3D effect. And this is a whole lot of individual steps which you have to write in SVG. So this bottom right image, of course, is actual text, which is filtered using this style of technique. So the beauty of doing something like this is you get these incredible graphics, but they're accessible and they're real text, so you can select them, you can do all sorts of stuff. So the thing about trying to do something like this in SVG is you need quite a lot of markup. So along came CSS filters, and CSS filters are basically a beautiful little shorthand that saves you a lot of pain and a lot of markup. And this is how easy it is to use. So here we just have a class selector with saying filter, blur, 4 pixels. And so this takes the image on the left and blurs it by 4 pixels. So that's all the markup you have to do, whereas in SVG that would have been a whole ton of markup. Now what's nice about these primitives is that you can combine them. You can actually put multiple filters on your content. So for example, you just have to do something as simple as this. You just line them up one after the other. So here we have a hue rotate followed by sepia. So we've taken a picture from I/O last year, and we've just applied 2 filters in order. Now the thing to keep in mind is that you can apply as many filters as you like, and they'll be applied from left to right, one after the other, which is great because order actually matters. So in this case, we've shifted the hue and we've sepia toned it, but if we were to flip these around the other way, we'd have something like that. So as you can see, the color's actually different. They're exactly the same filters, just in a different order. See, sepia and bluish tinge. Okay, so the beauty of these CSS shorthands are that because people implementing browsers spend all day hacking code, because that's what we love to do, because there's a finite number of these shorthands, we can actually optimize those inside the browser. So right now in Chrome, most of these are hardware accelerated. So if you do a blur or something, you don't get the penalty you would have got 12 months ago. So there's only like 12 shorthands, and here is, of course, the definitive prefix version with the normal markup of every single filter being applied to something. Right, so without enough of my yakking, Well, let's just show you what we built first. We're going to start with the desktop experience, because that, of course, is something a bit special. And then we're going to show you this all running on mobile, which hasn't been shown before, by the way. So anyway, I'll pass over to Alexis, who'll run you through the desktop experience.
Okay, thank you, Alex. So this is the project that Adobe developed using content from National Geographic. It's a really beautiful article about the great sequoia trees. As I scroll down here, so I'm going to go through the different technologies that we developed to create this next generation reading experience. So as I start here, the first thing you see here is this drop cap. So what we use here to make this text follow the contour of the letter O, we use something called CSS shapes or CSS exclusions. And let me show you a little bit about how that works by inspecting that. So we set here the WebKit shape outside property with an ellipse, and that's what creates the shape. So this is a floated element, and the inline text just kind of flows nicely around it, which creates a great typographical look. As I scroll down, you see this image comes into view, and whenever these images come into view, and also this one I hover over, you can see how we change both the saturation and also the sepia. So let me also take a look at that. So just as Alex mentioned, this is one of the CSS filters. So by default, this has a sepia and a grayscale of 0.5. When we hover over that, we change that to none. So this is a video that's about the photo shoot that was done for this. As you can see, it runs a full screen, nice HTML5 video. Let's see. All right. As I scroll down here, we see something, this pull quote, and the pull quote uses something called text balancing. Now, text balancing is still a proposal, so this was implemented using a JavaScript polyfill. And what it does is it ensures that each line is roughly the same width. So instead of specifying where you want your breaks, using text balancing, it will automatically be formatted. So if I resize the window enough, you'll see that now the text becomes 3 lines. You drag that here. So instead of where the browser would normally move things over word by word using text balancing, you always get this great formatted text regardless of the width. Again, here, this image comes into view. We change the opacity filter. I can click on it to put it in full screen. Now I'm going to talk a little bit about CSS regions. So this is a technology that we use here on the body text. And what CSS regions do is they let you define your content in one area in the DOM, but define the elements that the content flows through elsewhere. So the author has complete control over where the text will display without having to modify the markup itself. So you can kind of see that in action here, where we've got these 2 columns. If I select this text, you can see it pretty good because I resize the window. As you can see, the text flows from one to the next. So throughout this article, we define all these different regions in different places to position the text the way we want it to. Again, I scroll this image into view. You see it went from black and white to color. Here we use another CSS shape. As you can see, the text here roughly follows the background image. So that just creates a very nice look in combination with the photograph. So I can look at this one real quick. This was done using, let's see, WebKit shape inside and a polygon. So that defines the CSS shape that the text flows into. And now to scroll down here, we get to So here you see a thumbnail of the tree that Alex mentioned, the president. And what we wanted to do is create a visualization where you could actually see or kind of get an idea of just how immense this tree is. And to talk a bit about the technology behind that, I'm going to hand things back over to Alex.
Thanks, Alexis. Okay. Right, I just want to talk a little bit about triangles now. Down the bottom here you see a Delaunay triangulation. So normal filters are things that operate on pixels. So the basic filters we showed at the start, things like saturation and the color, the monochrome, those are pixel operations. When you get into the world of WebGL and shaders, you have two types of shaders. You have per pixel things, which are also called fragment shaders, but you also have vertex shaders. And what they do is basically take an object or a polygon, chop it up into triangles, and then you can write a shader program which manipulates these triangle points. The beauty of that is it all runs on the GPU. And so in this case, we're going to kind of introduce WebGL and what a proposal called CSS Custom Filters, right? So a lot of people are already familiar with WebGL, and we're going to show you WebGL in a moment with one of these experiences. But also CSS Custom Filters are slightly different. The difference with CSS Custom Filters are basically that CSS Custom Filters operate on any arbitrary web page content. So you can take a normal web page and effectively flatten it to a plane and then manipulate it using a shader program. Now, why would you want to do this rather than use WebGL is a question people have asked me. Because it's really easy, because WebGL actually takes quite a lot of JavaScript to set up, and also WebGL has no access to the DOM or any of the content on the page. The thing about using something like a CSS custom filter is that you can take advantage of the really good typography that's inside the browser. So most browsers these days rasterize with subpixel anti-aliasing, and that doesn't happen in WebGL, right? Or Canvas for that matter. So by using a custom filter, you can actually take advantage of that. So if you can imagine this page here with text and a bit of SVG graphic, what you would do is you would basically draw a triangle mesh over the top of it, and then you would write a shader program which would manipulate your web content. And if you took this and did that, you'd end up with something that looks a little bit like this. Okay, so here is a CSS shader. This is actually rendered by the browser and being manipulated. And so it's the content, it's moving around. So you can do things like page flips or deformations or things like that, which is kind of a really nice effect. So in any case, why don't we actually have a look at this? I would like you to pay close attention. Right, so here we have the president. And we wanted to have the experience where we actually brought forward the sheer size of this tree. And when they built this thing, it was like, how do you actually represent an image? Like the thumbnail here, you don't actually get a feel for how big it is. So pay close attention, look at the start. I want you to observe something and watch the tree fly in. Okay, so what's happening here is there is a gigantic image of the tree that's been sliced up into tiles. And they're all flying in. This is all WebGL. And as it comes in, you see at the bottom that there's a person right there. And there it is. So it kind of gives you a feel of how big this actual tree is. Thank you. And as you can see, of course, there are people up here in this tree somewhere. And it pans around beautiful. Look at that. It's basically nice and smooth. And this is all WebGL accelerated. Now, the astute people in the audience may have noticed right at the start of that tree flying in, there was a little graphic that appeared for a fraction of a second. And what was happening there is that we were trying to get the texture from CPU memory over into GPU memory. So the way this has been built is by constructing a giant texture, slicing it up into rectangles, and then referencing them from the WebGL context. But of course, this is one huge texture, and that takes time to get across into GPU RAM. So that little spinning thing that you saw just before the tree appeared was actually referencing the WebGL texture in a 1 by 1 pixel kind of reference. And so that 1 by 1 pixel reference was enough to pull the whole texture across so that when the tree flew in, it was actually nice and fluid. It's kind of a nice, neat little trick. Now, the other thing is also here that this is very similar to DOM spriting. So people who have done DOM spriting, you typically load one big image because you don't want to have all these HTTP fetches. So it's a very similar technique, except this is done WebGL and textures. Okay, so on that note, I will let Alexis take over and show you a little bit more about this experience. Now, this was WebGL. A little bit later on in the experience, he'll show you CSS Custom Filters in action on some of the content. So over to you.
Okay, thanks, Alex. So I scroll down through the article, and once again we see another image. We change the opacity filter once we scrolled into view. Here once again we see another CSS shape. As you can see, this time the text follows the contour of the base of these trees here. Again, looks great as part of the image. Very hard to do without this technology. Scrolling down to the end of the article, I get to this map. And there's a couple of things I want to show you here. First of all, we see yet another CSS shape. This time we follow the shape of the state of California. And as you can imagine, if you try to do this today, you would have to either do this using an image or by hand coding every single line here. And you can imagine that the problems with that. I mean, anytime you need to make a change, you'd have to actually go in and change the text and redo the entire graphic. You wouldn't get the indexing or searching that you get by all this just being text. So that just makes it a very useful technology to have for any kind of typographical effect like this. We also have here an infographic. Click here. This is a SVG graphic. It shows you the elevation range of the sequoias. We use more exclusions here for this text. And now to show our CSS filter in action here, once I click on this button, you can see the page peels away to reveal this other content. And let me actually go back and show that again. So you can see this is all just HTML, CSS content. And we use a custom shader or custom filter or a CSS shader to do that. So this brings another infographic. Here we can see the tree. I can click on these different parts of it to reveal the different sections. We did this using 2D canvas. And so that about wraps it up for the desktop, the browser experience. And I'd like to mention that you can actually, anybody can see this. We have it on GitHub. We'll share the link of this with you later. But when you do, let's go back to the top here. At the bottom here, there's a bar that says Show Editor's Marks. If you click on that, that shows this annotated view that actually highlights the different technologies that I've just been through. So you can see for yourself how we designed this page. Great, back to you, Alex.
Thanks, Alexis. Alrighty. Now, of course, we told you we're going to talk about mobile because this stuff was shown last week at Max, which is great. But today we're actually going to show you this running on a mobile device, and it blows your mind to see how far this has come and how fast it is and how beautiful the experience is. But of course, when you're building stuff for mobile, performance really matters, right? So nothing comes for free. So the most important thing is to test on many, many devices, or especially your target device. Really think about how much memory you're using, both for RAM and texture memory if you're using WebGL or custom filters. There are a couple of sessions coming up. I highly recommend you see them. There's a session directly after this one in this room, which is web page design with the GPU in mind. I highly recommend you listen to that one and a few others. So while we were building, or while these guys were building the mobile experience, it came to how would you actually deploy this on mobile today? And of course, you can just take Chrome on your mobile device and point it at that website that we've just shown you, and it works great. The thing is that for a next generation reading experience, people are used to like the whole app model. Maybe we download an app, it gives me my little icon that I can tap on, and it's a self-contained thing. I don't have to type a URL or anything like that. So it gives you a few options. So there are options whether you want to go completely native, or whether you want to have just a website, or whether you go to some kind of packaged web container like PhoneGap. And so this experience we're about to show you was built using PhoneGap. It's an experimental build that enables a whole lot of features that currently aren't in browsers, but it does show you the capability, and it's pretty cool. So why don't we take a little bit of a look at the National Geographic experience on the Nexus 10.
Okay. Thanks, Alex. So just for those of you unfamiliar with PhoneGap, PhoneGap is a framework that lets you create applications using web technologies on different platforms. it also gives you access to the APIs that you would not normally have access to in the browser. So we use that to create this. And so I'm going to launch this app. As you can see, when it starts, we start with the same WebGL animation. As you can see, it's very smooth, very slick, looks beautiful on the device. And once that completes, that brings us to this table of contents view. So here I can select our article. And so for the application experience, we wanted to do something other than just have some vertically scrolling page as users expect on the web. So in this case, we've got a paginated reading experience where I can scroll horizontally through the content. So here we see the same content that we saw in the browser, so we have the same exclusion here around the letter O. We also have some interactive elements. Here I can use multi-touch to take this picture and enlarge it. And as you can see here, it makes a lot of sense to also use regions to define each container for the text to flow through. So that gave us a lot of freedom exactly to define how we wanted the content to appear without having to modify the text that was actually in, or the paragraphs that make up the content. So we see here, again, we have text balancing, regions, and this brings us to our first use of a CSS shader on mobile. So what you can see here, once I put 2 fingers on this image, we flip to show the other part of the image. I can move my fingers around. I can open and close, and if I open them up, that shows this image in full screen. As you can see, when I scroll, you can also see how the lighting changes. So that's all done using the GPU. It's a beautifully smooth, high frame rate experience. You move through the content, and we see another beautiful image. Again, the CSS shapes that we were seeing before on the web experience. And once again, here's another image. If I tap on that, it flips out to show the full screen. And this one too, I can use the multi-touch to open and close. And so this creates a great experience for the users that you'd normally only see on native applications. And so we're very happy to be able to bring this to the web. Here we see another map that we also saw on the desktop. This one has the same page curl that you saw, except this one does something a little bit different, where if I move my finger, you can actually see how the content, how the page curls depending on the position of my finger. As you can see, it runs great. I let go, and this reveals a Google map. Because since we're using web technologies, it means that we can use APIs like the Google Map API. And now I can actually zoom in and see the location of the national park where the sequoias grow. And after that, I get to our last page. We see the same infographic before. I can use multi-touch to make this one bigger, and we see that in full screen. So that about summarizes the mobile experience. There's one more thing I'd like to show here, which you might find interesting, and just to prove that these are indeed web technologies. What we can do here is we're going to plug the tablet into this computer and run an ADB command, which lets us communicate with the Android device. And
I'm going to switch back to Chrome.
So if I switch back to the desktop.
Okay, so we're just going here to another tab, which we're going to point it at localhost with, and hopefully we'll see the page. So what we actually see here is a reference to the content that's actually running on the tablet. So this lets us pull up all the Chrome developer tools and actually debug the experience. So this is the huge advantage of taking this approach for a mobile application. So because it's built on web technology, you have all the tools at your fingertips, you can debug the entire experience, and you've seen the performance, so you get a really native style performance thing built with web technology, and you can debug it properly, like no more printf or ADB logcat, right? You can actually use proper tools. So why don't I just flip back and forth? Alexis will highlight a few elements in this, and we'll just prove to you this is
so this is me
real thing.
Turning on and off the shape inside property here, for example.
So here you go. He'll play with the shape inside property, and we'll watch it change live on the device. So go back.
Okay. So that was that right there. Okay.
All right. So this is a huge advantage of using web technologies for this kind of application. It's really, really nice way to do it. Now let's just, oh. You have to wait for that one. Okay, so what's next? The next level of CSS filters. So we've shown you the basic filters that are already there, the custom filters which are in development at the moment. Another thing that is already in the browsers today but is improving rapidly are SVG filters, and the reason they're really improving rapidly is because they've been thrown at the GPU. So right now in the channels of Chrome, there's hardware accelerated SVG filters coming. They're actually implemented now. They're just not finished completely yet. However, what this means is that you can take all those building blocks I showed you at the beginning of the presentation, and you can chain them together any way you like, and it all runs on the GPU, which is just sensational. So if you can imagine this picture at the bottom, this beautiful clear picture, this is in actual fact a movie with a displacement filter on it. And how do you do that? You do it with something like this. So the markup is very, very simple. So here's an element selector for video, and it's applying the filter with a URL reference, and you can see it references an ID. So that's basically how you apply it to your content. And then in the SVG, which I expect people will share filters between each other, there are two filters shown here. One is a convolution filter. So you can basically use an arbitrary convolution matrix and apply it to your content. The second filter applies a blur followed by a convolution. And this all runs in the browser hardware accelerated, and I will prove it to you by showing you this. Okay, here is a nice little movie with no filter on it. But of course, if we were to put a blur on it, it would look something like this. So there you have it, full speed video with blur, hardware accelerated in the GPU. But of course, SVG has a whole lot of primitives. So here is a point light filter. And what's nice about this is there's a little event listener on mouse move here, which actually moves the position of the light. So this is all happening in your favorite browser, or my favorite browser anyway. So there's also a spotlight. There are a few different lighting primitives in SVG, which are really quite nice to do all sorts of amazing effects. We have a morphology filter, which I don't know if it's applicable to video, but anyway, it works. You can flip the colors around, you can play with the color channels and do all sorts of crazy things. Now here's the convolution filter that I showed in the previous slide. So this is actually a convolution matrix that is doing edge detection. And so it gives you this kind of line art thing. And if we actually use the second filter on the previous slide, there's the blur followed by the convolution. It gives you this kind of result. So a blurry line art, thing. All right, so we can do offsets. So you can basically offset your graphics. So you don't even need to use relative positioning. You could actually do it with a filter if you really felt like it. Then, of course, we can play with a retro feel. We can go to black and white. Actually, that's kind of cool, isn't it? But you can do anything with the color channels. That's the beauty of it. You can do all sorts of stuff. So we could do a noir effect, which is kind of a funky, old style thing, or do a bit of blue, so you can imagine that you're in the ocean. And of course, we'll finish up with the displacement filter. So the displacement filter is a really useful one, and I can't wait for you guys to get out there and start playing with this one and build all sorts of crazy sites. So if you can imagine when you're on your desktop and you've got Windows up, you iconize it and you see the rectangular thing go like a genie back into a bottle. Well, the displacement filter lets you do things like that. So in effect, it's a warp. But what it does is it takes an input image and uses one of the R or G or B color channels and uses the value in the pixel as an offset that's applied to the content. And so this is an example Actually, we should probably go further forward in the video. Why don't I go somewhere there? That's better. So you can actually see the content is really crazily warped around with this input image with the displacement filter. Okay, so what I really want everybody in this room to do is go to their favorite site and put CSS filters on it, because you can do some incredible stuff, and we're hardware accelerating the whole lot of it now, and so it means that your sites just gives you another piece of creative sugar to put on top of your sites and make them beautiful. Now, this National Geographic experience which we showed you today, the whole thing is open source, so if you go to the URL at the top, you can actually get a hold of all the content, so you can see how it was built, see everything. Use the content. The second link there is a link to the actual experience itself, so you can view it. I'd encourage everyone to start playing with this stuff, looking at it, seeing what they can do. Your browser's there, you can debug it on mobile if you really want to. And with that, I think we're pretty much done. What do you think, Alexis?
That's right.
Okay, we've got plenty of time for questions, so do we have any?
One other point.
Oh, yes. One other thing. We'll be up at the Chrome sandbox right after this talk, so if anybody has further questions they don't want to ask now, come and visit us. And also on level 3 of the Adobe sandbox, they're actually showing this on the Nexus 10, so you can get your own fingers on it, play with the mobile experience and see it for yourselves. So anyway, questions?
I got here late, so I'm not sure if you already addressed it, but I was wondering, I realize it's mostly taking place on the GPU, but how's battery consumption with all that animation?
Well, in fact, battery consumption is reduced when you throw it on the GPU.
Right.
So typically, the GPU uses a lot less battery power to do any of these kind of effects. So it's pretty cheap, actually.
But do you know what the percent reduction is? Because I know that playing video on a phone would be a lot of battery consumption.
Playing video on the phone, I think you probably find a lot of the battery consumption is actually the radio being on and pulling the content across, right, more than the GPU itself.
Well, okay. Thank you.
Sure. Yes?
Hey, is there any way to determine how much texture memory the device that you're on has for the WebGL stuff? Because I saw you guys, the image for the tree was pretty large.
Yeah.
Do you ever hit a maximum where it just stops working or it crashes?
That's why I said test, test, test. We are actually looking at ways to measure GPU memory. This has been asked quite a number of times from a lot of mobile developers, and we don't have a good answer for that just yet. But come to the next session, and I'm sure they'll tell you all sorts of cool tricks.
Cool, thanks.
I've been playing with CSS filters, and I've been surprised a few times when some things are accelerated and other things aren't. Is there a rule of thumb that I can follow that will help me decide whether or not this is going to be GPU accelerated?
I don't know that there's any clear rule of thumb. We accelerate all of them in Chrome now, and I know that Mozilla have just re-architected the whole back end of their rendering pipeline, and they'll be accelerating all theirs as well. In general, if you're scared, just don't use blur, because blur is the only one that really hurts you in software rendering. The rest of the filters are pretty good. Or if you really want to use blur, because it's useful, make sure you keep the blur small, because it's the square, like it's an order n squared. So if you do a 2-pixel blur or a 4-pixel blur, the 4-pixel blur is 4 times the 2-pixel blur in terms of cost of rendering.
Got it, thanks.
Yeah. John.
So what are the requirements on mobile in terms of WebKit, and can you talk a bit about what you've actually contributed to PhoneGap to make it all work?
In which respect?
Actually, I'll ask a simpler question. What version of Android is a minimum to run something like this on?
Well, PhoneGap question. Alexis, can you tell us, what's the minimum Android for PhoneGap?
I think just PhoneGap, the basic PhoneGap should just run on, I believe, most Android versions, including 2.x. But what we did here today, that we actually used this custom version of PhoneGap to make this possible, so we could have the hardware acceleration working as smoothly as possible.
So does that need a custom version of WebKit, or are you using
it's both a custom version of PhoneGap and a custom version of WebKit, yes.
Right, okay.
Can we get that version?
Not yet. But,
the question was, can you get that version?
So it's just a very prototype stage, so we hope eventually the code that Adobe's been working on, we hope that might get into Blink or WebKit eventually, but don't quite know for sure now. No time known yet.
Okay.
Thanks.
So,
So you mentioned subpixel rendering and then applying filters, which seems weird to me because once you've subpixeled it, if you filter it, it no longer hits the subpixels.
Well, what I was saying was that you could do the subpixel rendering, but then you can do like a vertex shader, right, which will manipulate the content. So for something like the page flip, for example, the filter is only moving the content around.
So not when it's static, right?
Yeah, so you still get the nice clean typography, but so the filter's not actually messing with how it looks.
But you presumably get sparkle when you do that then, because of the subpixel.
Oh well, the subpixel rendering is there, right? So that as the page is flipping, you don't suddenly see a flip from nice typography to blocky grey anti-alias as the page flips, right? So it stays nice. Do you understand? Yep.
Yeah, that makes sense.
Yep, cool. All right. Yes.
Hi. I'm just wondering if you can say anything about the designer experience of doing a site like the National Geographic one. Did you have to design custom tools, or was it done in a text editor for some of these special effects, or how did you set that up?
So are you just asking about the custom filters?
Well, perhaps you guys designed the pages yourselves, but I'm wondering if maybe a regular graphic designer came in as well and had a visual layout tool.
It was all designed by Adobe. National Geographic gave us content and gave us a little bit idea of what kind of layout they had in mind, but the whole design process and implementation was done by us Adobe guys. And so the CSS filter that we used was the one on the web is actually, if you go to CSS Filter Lab, if you just Google CSS Filter Lab, you can see a whole bunch of filters that we actually developed at Adobe. And so the page scroll one is one of those, and that's what we included there. So that answer your question?
I guess so. I guess I'm just trying to think about it in terms of if I'm not, to address somebody who's not a programmer, but who might want to say, oh, I really would like to have
well, because
this page pinch open right here, but I don't know how to do that.
Well, because this is still in very early stages, there's not a whole lot of tooling for it yet. Even the spec is still being developed, but I can promise you that Adobe specifically will make sure that this will become easier for developers.
Yeah, I think you need to follow the Adobe Web Platform blog because they're developing a ton of tools. They've got like a whole swathe of tools and more are being developed. So we're kind of showing you leading edge stuff that's still active in browser development and standards development. And so once they're kind of locked down, they'll be producing tools for this stuff for sure.
Oh, cool. Thank you very much.
Okay. Yes.
So my question pertains to availability and compatibility. So I just gave the website that you were demoing a try on Chrome 28 on my Pixel, and it said I needed to turn on WebKit, experimental WebKit features, and I did, and it runs great, and that's awesome. But do you happen to know the timeline on when that will be in the general Chrome release?
Very good question. I think that this is one of those open-ended questions because some of the features like the simple filters and the SVG filters all work currently. They're all standardized. The custom filters and some of that stuff and the regions and exclusions are currently going through the standardization process in W3C. And so that's a kind of open-ended thing. I can't give you an answer of exactly when, hopefully soon. But for now, this is basically an example of where the technology is being developed in parallel to standardization so that when we go to the W3C and other browser vendors, it can go, look, here's an implementation, it works, it's cool, and then everybody can argue out the fine detail of how that will finish up at.
All right, thank you very much.
Yep, welcome. John, another question.
My second question, I'm actually excited about this. One of the issues I've had with mobile web is having to deal with different versions of WebKit on different platforms. So are your contributions to Cordova, does that mean I can pick a version of WebKit and deploy that? No.
No, for Cordova, you're stuck with a WebKit that is on the device.
Right. Okay, so
I believe there's talk of possibly changing that in the future, but that's the way it is now.
All right, okay. So my first question then, doesn't that mean there'll be minimum requirements for the mobile OS for me to use these features?
Yes, that's correct.
All right. Okay, thanks. I'm less excited.
Get excited, John. It's good. Okay, yes, sir.
On mobile, I understand test, but I wonder if amongst the different mobile graphics accelerators, you've noticed that certain of these operations perhaps tend to work well and others maybe not so much.
Yes, very good point. One of the things about the mobile GPU to keep in mind, I mean, the next session we'll dive deep into this stuff, but the technique of rendering on a mobile GPU is completely different to a desktop. So on a desktop GPU, you basically have a ton of parallel execution units, and so your rendering goes blat in a huge wide thing and happens instantaneously, and it's brute force, right? Whereas on a mobile device, because you want to keep the silicon small, they use this kind of deferred rendering technique where they buffer up all the things that are going to be drawn and kind of build display lists and a stack of stuff and try to then eliminate the things they don't need to draw and then draw it. So because of that, you actually end up using a whole lot of memory in the process. But one little tip that's really useful when doing this stuff on mobile is to try and keep the pieces of your content small. So, for example, if you're doing like a long list, like an infinite list style of thing, and you have a long, thin strip like this, if you go put a translate Z hack or something like that to force it into the GPU layer, the problem with doing that is that textures have to be square. So if you've got a long, thin strip like this, maybe it consumes 1 megabyte, but your texture, your square texture could be 100 megabytes. And so you've blown out all your GPU memory, and I've seen really janky sites where people have done this, and then simply by changing the CSS selector to put that transform on the little pieces of content within the strip, you would think that would cost more time because of all the extra CSS style recalculation. But in actual fact, what happens is the tiles end up these little tiny tiles that then go over to the GPU and the thing flies. Right, so as a general rule of thumb, try and keep content that's accelerated small. So, and especially like with the WebGL tree, you saw it was all chopped into little squares or little rectangles. That was a similar kind of idea. Okay?
So following up on that, with the WebGL tree, you mentioned how difficult it is to get the texture to the GPU,
yep.
And that you put a little spinner in there to make it more a better user experience. Would you have this problem with GPU accelerated CSS filters or even custom filters, and what can you do about it? Is there a lag due to the texture going to the GPU when you use those pre-built filters?
You would have that problem with the custom filters because it's the same issue. You have to get the texture of the rendered content. So effectively your browser is laying out rendering, and then it's creating a bitmap which it then passes across to the GPU for it uses as a texture. Right, so you will have that problem for those filters. For the SVG filters, not so much, because, well, I suppose you would. I guess it depends on your content. But if you're playing video, for example, where I showed the SVG accelerated filters on the video is already on the GPU. Right, so that bitmap of the video is never seen on the CPU side. It's decoded in hardware. That's sitting like in the GPU memory, and then when the SVG filter is applied, it's all happening as a texture in GPU memory, so there's never a read back to CPU, so you don't get the same flip-flop of textures happening.
And so if you have the issue with CSS Custom Filters, is there anything you can do for displaying a spinner, for instance?
Probably lots of things. Well, similar to displaying the spinner, but I think that you'll probably find that will just be like an initial load, because if the custom filter is sitting there, right, the browser already knows it needs to put it in a texture. So the moment you see it, it's ready to go to do its flip effect. It's just how quickly that loads. I think in the actual National Geographic one, because the custom shader was down the bottom, custom filter was right at the bottom of the page, that was just loading in the background while you were viewing the top. So your standard kind of techniques show something to the user as the fancy content is loading in the background.
Okay, thanks.
Okay. Yes?
Are you tracking sort of fine-grained abilities of what works on Can I Use for these? Which filters are on which platforms?
I believe filters is a feature that's on Can I Use. I think it's just basic filters right now, but yeah, as that gets more complicated, then I'll definitely add more sub-features or whatever.
Yeah.
So I don't know whether this is just Moscone Wi-Fi being Moscone Wi-Fi, but the website that you guys were using, the GitHub site, to demo the National Geographic thing, stopped working. I refreshed the page and it says it can't connect to that. Can you know if that's a connection problem, or is that being moved somewhere? Or
I think it's a connection problem. So this is this is the page. So
okay.
Yeah.
if I reload it, then again,
Okay.
maybe it's Moscone Wi-Fi.
Okay, thank you.
This is actually a wired connection. So yes.
Oh, thank you.
Looks like the network is down, folks. Sorry about that. Okay. All right. In that case, no more questions. Anyone quick? One last question. No one brave. All right. Thanks everyone for coming to this session.